Hello, student. In today's class, I am discussing the chapter of mathematics trigonometry. Firstly, I will discuss all the formulas of trigonometry function, general solution of trigonometry function, and inverse trigonometry function. Okay. Then I will solve previous year questions of your board. After that, in next class, when these chapters are completed, I will tell separately the hyperbolic function and separately the or you can say that general solution of trigonometry. General solution of trigonometric function. General solution of trigonometric functions. And in last, we will discuss inverse trigonometric functions. Inverse trigonometric functions. Inverse trigonometric functions. Generally, trigonometric word derived from the word tri. Tri means triangle. Gonometry means study of triangle. Okay. So in this chapter, we will study the parts of triangle. Suppose this is a right angle triangle A, B, C. Side opposite to 90 degree is known as hypotenuse. Suppose this angle will be theta. So side opposite to theta is known as perpendicular and the side which was left is known as base. Okay. So hypotenuse, perpendicular, base. Now, what are the trigonometric functions? There are six trigonometric functions. First is sine theta. Sine theta is perpendicular upon hypotenuse. Second one is cos theta. Cos theta is base upon hypotenuse. And third one is tan theta. Tan theta is perpendicular upon base. Now, reversible of sine is cosec. Cosec theta is 1 upon sine theta. Or you can write it as hypotenuse upon perpendicular. Inverse of cos theta is sec theta, which is equal to 1 upon cos theta. Hypotenuse upon base. Next one is cot theta. Cot theta is 1 upon tan theta. So 1 upon tan theta is equal to base upon perpendicular. So these are all six functions, all six trigonometric functions: sine theta, cos theta, tan theta, cosec theta, sec theta, cot theta. Now, suppose this is a triangle A, B, C, in which AC is hypotenuse and AB is perpendicular, BC is base. We know the Pythagoras theorem. By Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square. Now, firstly, I am dividing the equation by In firstly, I am dividing equation by hypotenuse square. So what happened? Hypotenuse upon hypotenuse square is equal to perpendicular upon hypotenuse square plus base upon hypotenuse square. So hypotenuse square upon hypotenuse square is 1. Perpendicular upon hypotenuse square is sine. So 1 is equal to sine square theta plus cos square theta. Now secondly, I am dividing the equation with perpendicular square. So what will happen? Hypotenuse upon perpendicular square is equal to perpendicular upon perpendicular square plus base upon perpendicular square. So this term will be cancelled, which is equal to 1, and base upon perpendicular is cosec theta. Sorry, sec cosec theta. So wait, sorry. Base upon perpendicular is cot theta. So 1 plus cot square theta is equal to hypotenuse upon perpendicular is cosec theta, cosec square theta. Now, if I divide the equation with base square, so I will get hypotenuse upon base whole square is equal to perpendicular square upon base square plus base square upon base square. So this term will be cancelled. Perpendicular upon base is tan square theta. So plus 1 is equal to sec square theta. Okay, now I'm writing all formulas. First is sin square theta plus cos square theta is always 1. Next formula is 1 plus tan square theta is equal to sec square theta. Next formula is 1 plus cot square theta is equal to cosec square theta. Now the formula of sin is sin A plus B. So sin A plus B is equal to sin A cos B plus cos A sin B plus cos A sin B. Next formula sin A minus B. So sin A minus B is equal to sin A cos B minus cos A sin B. Now the next formula is cos A plus B. So cos A plus B is equal to cos A cos B minus sin A sin B, and cos A minus B is equal to cos A cos B plus sin A sin B. Now, if you sorry, next formula is tan A plus B. Tan A plus B is equal to tan A plus tan B tan A plus tan B upon 1 minus tan A tan B. Next, the formula of tan A minus B. Tan A minus B is equal to tan A minus tan B upon 1 plus tan A tan B. Now the formula of cot A plus B. You can write cot A plus B as 1 upon tan A plus B. Firstly, solve for tan A plus B, then you can get the value of cot A plus B. Or if you want to solve by directly by formula, so the formula of cot A plus B is cot A cot B minus 1, cot A cot B minus 1 upon cot A plus cot B. Next is cot A minus B. So cot A minus B is equal to, which is inverse of 1 upon tan A minus B, or direct, if you want direct formula, then the cot A minus B is cot A cot B plus 1 upon cot A minus cot B. So these are the formulas of single form. Okay. Now I am applying the formula of 2 sin A cos B or 2 cos A sin B or 2 cos A cos B. We know that sin A plus B is equal to sin A cos B plus cos A sin B. And sin A minus B is equal to sin A cos B minus cos A sin B. Now, if you add both this, So what will happen? In firstly, I am adding both. So sine A plus B plus sine A minus B is equal to 2 sine A cos B. Now I am putting A plus B as C and A minus B as D. So A plus B equal to C or A minus B equal to minus D by 2 is equal to B. So the new formula of sine A plus B will become sine C plus sine D is equal to 2 sine C plus D by 2 and cos C minus D by, okay. The formula sin A plus B plus sin A minus B or sin C plus sin D equal to 2 sin C plus D by 2 or cos C minus D by 2. And if you subtract, then what will happen? Sin A plus B minus sin A minus B is equal to cos A plus cos A sin B minus minus of cos A sin minus sin A cos B plus cos A sin B. So 2 cos A sin B. So the formula will become 2 cos A sin B. Now similarly you can put A plus B equal to C and A minus B equal to D. A plus B equal to C, A minus B equal to D. If you add both these, so you will get C plus D by 2 equal to A and C minus D by 2 equal to B. So you get the formula sin C minus sin D is equal to 2 cos C plus D by 2 and sin C minus D by 2. Okay. Now the next question is, next formula is of cos. So cos A plus B plus cos A plus B is equal to cos A cos B. Cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B, and the formula of cos A minus B is cos A cos B plus sin A sin B. Now, if you add both this equation, so you will get cos A plus B plus cos A minus B. If you add LHS, then you have to add RHS. You will get the value 2 cos A cos B. So cos A plus B plus cos A minus B is equal to 2 cos A cos B. Now similarly you can put A plus B is equal to C and A minus B equal to D. If you add both this equation, on adding you will get C is equal to A plus, sorry, A is equal to A is equal to C plus D by 2, and on subtracting in both this equation you will get B is equal to C minus D by 2. So on putting A plus B equal to C plus D by 2, add A minus B equal, sorry, A plus B equal to C and A minus B equal to D, and A equal to C plus D by 2 and B equal to C minus D by 2, you will get cos C plus cos D is equal to 2 cos C plus D by 2 and cos C minus D by 2. So this is the formula of cos C plus cos D. Now, on subtracting, you will get cos A plus B minus cos A minus B is equal to 2 sine A sine B. Similarly, you can put A plus B equal to C and A minus B equal to T. Then you will get A is equal to C plus D by 2 and B is equal to C minus D by 2. So you will get a new 1 minute. Cos A plus B plus cos A minus B is equal to minus of 2 sin A sin B. So you will get the formula cos C minus cos D is equal to minus of 2 sin C plus D by 2 or sin C minus D by 2. If you want to put this minus sign inside, so you will get 2 sin C plus D by 2 and sin D minus C by 2. Sin D minus C by 2. So these are also the formula of cos C minus cos D. Now next formula is of sin A plus B into sin A minus B. Sin A plus B into sin A minus B. So sin A plus B into sin A minus B is always equal to sin square A minus sin square B. Or you can put sin square A is 1 minus cos square A and sin square B is 1 minus cos square B. So 1 minus cos square A minus 1. 1 will be cancelled. So cos square B minus cos square A will be the second formula of it. So sin square A minus sin square B and cos square B minus cos square A. Now the formula of cos A plus B into cos A minus B. So cos A plus B into cos A minus B is equal to cos square A minus sin square B. Now if you put inside of cos square is 1 minus sin square A minus 1 minus of cos square B. So you will get a next formula cos square B minus sin square A. Cos square B minus sin square A. So all these are the formulas of trigonometric functions. Okay. Now the next formula is of sine theta. So sine 2 theta. The formula of sine 2 theta is 2 sine theta cos theta. And the next formula of 2 sine 2 theta in terms of 10 is 2 tan theta upon 1 minus tan square theta. Now the formula of cos 2 theta. So cos 2 theta is equal to cos square theta minus sine square theta. Next formula is if you put sine square theta in place of sine square theta as 1 minus cos square theta. So you will get next formula as 2 cos square theta minus 1 is equal next formula 1 minus 2 sine square theta and is equal to 1 minus tan square theta upon 1 plus tan square theta. So these are the formula of cos to theta. Now, second one, the formula of tan to theta. Tan to theta is, sorry, here is 1, 2 tan theta upon 1 plus tan square theta. The formula of tan to theta is 2 tan theta upon 1 minus tan square theta. Now, the formula of sine 3 theta. Sine 3 theta is formula 3 sine theta minus 4 sine cube theta. And the formula of cos 3 theta is 4 cos cube theta minus 3 cos theta. The formula of tan 3 theta is 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So all these are the formula. Now next formula is sine theta into sine 60 minus theta, or in place of 60 pi by 3 will become pi by 3 will come, or sine into sine 60 plus theta is equal to 1 upon 4 times of sine 3 theta. Now next is cos theta into cos 60 minus theta into cos 60 plus theta is equal to 1 upon 4 times of cos 3 theta. Now next formula is tan theta into tan 60 minus theta into tan 60 plus theta is equal to tan 3 theta. So all these are the formulas of your trigonometric function. Now comes to the next part, the general solution of trigonometric function. The general solutions of trigonometric equations. General solution of trigonometric functions. I will define it. I will describe it in detail in previous classes. So I'm writing just a formula here. So general solution of trigonometric function. On one side, I am writing a trigonometric function or trigonometric equation, and on one side, I am writing its general solution. General solution. Okay. Only I am describing the formula here because this is a revision batch. In normal classes, I have defined all these formulas. So if there will be a revision batch again, means live classes, then in that class I will describe all these questions. Okay, all I prove all these trigonometric equations. If sine theta equal to 0, so you will get the value of theta as n pi, theta equal to n pi, where n belongs to integers, z denoted integer. If cos theta is equal to 0, so you will get theta is equal to 2n plus 1 pi by 2, 2n plus 1 pi by 2, where n belongs to z. Now, if tan theta equal to 0, so you will get theta is equal to n pi, or n belongs to z. Now, next is if sine theta equal to sine alpha, if sine theta is equal to sine alpha, so you will get theta is equal to n pi plus minus 1 to the power n alpha, or n belongs to z. Now next, if cos theta is equal to cos alpha, so you will get theta is equal to 2n pi plus minus alpha, where n belongs to z. Now next, last, tan theta is equal to tan alpha. So you will get the value of theta as n pi plus minus n pi plus alpha, n pi plus alpha, where n belongs to z. Now in the last, if tan square theta equal to tan square alpha and sin square theta equal to sin square alpha and cos square theta is equal to cos square alpha, in all three cases, you will get the same value. Theta is equal to n pi plus minus alpha, and where n belongs to z. So these are the general solution of trigonometric equation, that if sine theta equal to 0, then theta is equal to n pi, where n belongs to z. And if cos theta is equal to 0, then theta is equal to 2n plus 1 pi by 2, where n belongs to z. and tan theta equal to 0, then theta equal to n pi. And if sin theta is equal to sin alpha, then theta is equal to n pi plus minus 1 to the power n alpha, where n belongs to z. And if cos theta is equal to cos alpha, then theta is equal to 2n pi plus minus alpha, where n belongs to z. And if tan theta is equal to tan alpha, then theta is equal to n pi plus alpha, where n belongs to z. And in all three cases, if tan square theta is equal to tan square alpha, sin square theta is equal to sin square alpha, or cos square theta is equal to cos square alpha, you have to give us the general solution of all these equation is theta is equal to n pi plus minus alpha, where n belongs to z. Now, firstly, I am Now, firstly, I am giving I solve some questions. After that, I will prove all the trigonometric for all inverse trigonometric formulas for you. Okay. Question is, if a plus b plus c is equal to pi by 2, then then prove that cos 2a plus cos 2b plus cos 2c is equal to 1 plus 4 sine a sine b sine c. So 1 plus 4 sine A sine B sine C. Now the solution of the this question is A plus B plus C equal to pi by 2. And in LHS, we have cos 2A plus cos 2B plus cos 2C. Now applying the formula of cos A plus cos B, which is equal to 2 cos A plus B by 2 and 2 cos A plus B by 2 and cos A minus B by 2. Okay, in place of A, we have 2A, and in place of B, we have 2B. So the formula will become 2 cos 2A plus 2B by 2 and cos 2A minus 2B by 2 plus cos 2C. So it which is equal to 2 cos A plus B into cos A minus B plus cos 2C. Now in place of A plus B, I can write A plus B is equal to pi by 2 minus C. So in place of A plus B, I can write pi by 2 minus C. Okay. So 2 cos pi by 2 minus C into cos A minus B, and applying the formula of cos to c, which is equal to 1 minus 2 sine square c. So sine 90 minus theta is cos theta, which is equal to 2 sine c cos a minus b plus 1 minus 2 sine square c. Now if you take 2 sine c common, so 1 plus 2 sine c common, so what you will get in first term, you will get only cos A minus B, and in second term, you will get minus sine C. Okay. Now the formula 1 plus sorry 1 plus 2 sine C is equal to cos A minus B, and since it is given that A plus B equal to pi by 2, A plus B plus C equal to pi by 2, so I can write C as pi by 2 minus A plus B. So in place of sine C, I can write sine pi by 2 minus A plus B. So sine 90 minus theta is also sine theta. So which is equal to 1 plus 2 sine C cos A minus B and sine 90 minus theta is cos theta. So cos A plus B. Now apply the formula of cos A minus B minus cos A plus B, which is equal to 1 plus 2 sine C, which is equal to 2 sine A sine B. On multiplying, you will get 1 plus 4 sine A sine B sine C, which is equal to RHS. Because you have to prove cos 2A cos 2B plus cos 2C is equal to 1 plus 4 sine A sine B sine C, which is equal to RHS. Now one more topic has came here. Forgot to say uh, this one, the quadrant change. In first quadrant, all trigonometric functions are positive. First quadrant means which is belongs to 0 to pi by 2. And in second quadrant, pi by 2 to pi, sine is positive. And in third quadrant, which belongs to pi to 3 pi by 2, 10 positive. And in fourth quadrant, cos positive, which is equal to 2 pi, which is belongs to 3 pi by 2 to 2 pi. Now add 2 pi plus pi by 2, you will get a 5 pi by 2, and 2 pi plus 5, this also became pi. The cycle will be repeated again and again. The trick for it is add sugar to coffee. A means all positive in first quadrant, S means sine positive, and the inverse of sine is sine and cosec. Sine and cosec positive, rest all the function are negative in second quadrant. In third one, t means tan theta, and inverse of tan theta is cot theta. Here is t. Tan theta or inverse of tan theta is cot theta, positive in third quadrant. And in fourth quadrant, cos theta and inverse of cos theta is sec theta will be positive in fourth quadrant. Okay, so all these are the formulas. Now see the conversion. If there will be a odd multiple of pi by 2 and plus minus anything, if there will be an odd multiple of pi by 2 plus minus anything, then the trigonometric function will changes. Sin theta change to cos theta, and cos theta will change to sin theta. Tan theta will change to cot theta, and cot theta will change to tan theta. Sec theta will change to cosec theta, and cosec theta will change to sec theta. Now I'm giving you example such that sine 90 minus theta. So sine 90 minus theta is, suppose, 0, pi by 2, pi, 3 pi by 2, and 2 pi. You will take angle only in anti-clockwise direction. Sine 90 minus theta, this is 90, and below 90, suppose at this angle is theta. So sine 90 minus theta, 90 is odd multiple, so it will be changed to cos. So cos, and in first quadrant, all positive, so cos theta. Now next, sine 3 pi by 2 minus theta. Now take sine 3 pi by 2 minus theta. It will come in this quadrant. So now the angle will be yours like that. Sine 3 pi by 2 minus theta. That means it will below 3 pi by 2. So 3 pi by 2 minus theta. In this quadrant, sine is negative. You have to take the signs of trigonometric function before the conversion. Now sine 90 minus theta. Sine 90 minus theta changes to cot theta. Sine 90 minus theta, sine 90 into pi by 2. Pi by 2 into odd multiply. Na? Sorry, sine 90 into 3. Pi by 2 odd multiple, and in pi by 2 sine changes to cos. So minus cos theta. Okay. Now if there will be a even multiple of pi by 2, if there will be even multiple of pi by 2 plus minus theta, so sine will remain in sine, cos will remain in cos, tan will remain in tan, cot will remain in cot, sec will remain in sec, and cosec will remain in cosec. Okay. Now I'm drawing the quadrant 0, pi by 2, pi, 3 pi by 2, and 2 pi. Now, firstly, sine 180 minus theta. So, sine 180 minus theta. Suppose I am writing sine pi minus theta. So, pi minus theta means this is pi. The angle is below it. Okay. At angle theta. So, sine 180 minus theta. 180 is even multiple of pi by 2. I can write it as sine 2 into pi by 2, which is 2 means it is even. So sine 90 minus theta in second quadrant, all positive, sine positive. So sine will be positive, so the function will be positive. You have to take the sine before the conversion. Now, if you take the sine, means at that quadrant, sine will be positive. Now, sine 2 into pi by 2 minus theta will become cos, sorry, sine theta, because in even multiple they will remain in their identity. So sine 80 minus 180 minus theta is equal to sine theta. Now cos pi by 2 minus cos pi minus theta. So in cos pi minus theta, I can write cos 2 into pi by 2 minus theta. Now in the second quadrant, only sine and cosec are positive. So take the sign of cos as negative. Now cos 2 into pi by 2, which will become cos. So cos pi minus theta is equal to minus of cos theta. Okay. So all these are the all the basics are clear. Now I'm giving the next question. Next question is express root 3 cos 25 root 3 cos 25 degree plus sine 25 degree upon 2 as an sine of angle, as an sine of an angle, sine of an angle. So the formula of it is root 3 by 2 cos 25. I can separate the 2 on a by of everyone. So root 3 by 2 is equal to cos 25 plus 1 by 2 into sine 25. We have to express this in an angle of sine. So root 3 by 2, I can write it as sine 60. So sine 60 plus cos 25 into cos 25 plus I can write 1 upon 2 as cos 60. So 1 upon 2 as cos 60 sine 25. Now sine A cos B plus cos A sine B. So the formula of it will become sine 60 plus 25, which is equal to sine 85. All these are your previous year questions. Okay. Now the your next previous year question is express 1 minus cos theta plus sine theta, 1 minus cos theta plus sine theta upon 1 plus cos theta plus sine theta in terms of tan theta, in terms of tan theta. Now see here, since we know that the formula of cos 2 theta, cos 2 theta has two formula, 1 minus, oh, means they have four formula. Mainly there are two formula of cos and sine. So 1 minus 2 cos square theta, and next one is 1 minus 2, sorry, 1 minus 2 sine square theta, and second one is 2 cos square theta minus 1. If this one come toward this side, and if cos 2 theta by 2 come here in place of 2 sin square theta by 2 sin square theta, and minus 2 sin square theta comes in place of cos 2 theta, so you will get 1 minus cos 2 theta as 2 sine square theta. Now, if you have the angle, so you will get 1 minus cos theta is equal to 2 sine square theta by 2. If you have here, so you will have to have angle here. So 1 minus cos theta is equal to 2 sine square theta by 2. Now, in second case, if 1 come to a left hand side, so 1 plus cos 2 theta is equal to 2 cos square theta. Now, if you halve the angle both sides, so you will get 1 plus cos theta is equal to 2 cos square theta by 2. Okay. And now, nextly, the formula of sine 2 theta is sine 2 theta is 2 sine theta cos theta. Now, if you have the angle both sides, so you will get sine theta equal to 2 sine theta by 2 cos theta by 2. Okay. So these are the formula, half angle formula. These are known as the half angle formula. So the half angle formula of 1 minus cos theta is 1 minus cos theta is 2 sin square theta by 2. 1 plus cos theta is 2 cos square theta by 2. The formula of sin theta is 2 sin theta by 2 cos theta by 2. 2 sin theta by 2 cos theta by 2. All these are the half angle formula. Now the question is 1 minus cos theta plus sin theta upon 1 plus cos theta plus sin theta in terms of tan theta by 2. We have to express this question in terms of tan theta by 2. So 1 minus cos theta plus sin theta upon 1 plus cos theta plus sin theta. In place of 1 minus cos theta, I can write 2 sin square theta by 2. And in place of sin theta, I can write 2 sin theta by 2 cos theta by 2. In place of 1 plus cos theta, I can write 2 cos square theta by 2. And in place of sin theta, I can write 2 sin theta by 2 cos theta by 2. Now, if you take 2 sin theta by 2 common from numerator, so 2 sin theta by 2 common, so you will get sin theta by 2 plus cos theta by 2. And if you take 2 cos theta by 2 common from the denominator, so we will get common cos theta by 2 and sin theta by 2. So this term will be cancelled, 2 will be cancelled by 2. Sin theta by 2 upon cos theta by 2 is equal to tan theta by 2. Okay. So that's all your formula. That's all for today. In next class, I will discuss some more questions, and after that, we will discuss the formula of inverse trigonometric function, then of hyperbolic function, then of properties of triangle. Okay, and we will solve all the questions, all the previous year questions of these chapters. So that's all for